Welcome back, my far-reaching physics students, and I decided that I would do a couple of example problems for you. So these are going to be example problems on friction. So example problems for friction. So just kind of show you how does this work out. We talked about friction in two senses, static and kinetic. So you either have the friction that pushes against you when something is stuck there, that's static, and then when it's in motion, you always have a negative acceleration from friction. All right, so let's say we got a scenario. So let's say we've got these two guys. Let's call them Maddie, and let's call this one Jacob. And let's say that they just watched Charlie and the Chocolate Factory, and they decided that they would like to make life easier for themselves. So instead of walking around school, they decided to go on eBay and purchase some Oompa Loompas to pull them around on a sled. So they figured out that each Oompa Loompa can pull a 25 Newton force. And so then they built a sled for themselves, and they figured, well, you know, if we get enough Oompa Loompas, we should be able to get this sled pulled. So they got to save up their money, and Jacob's able to make money pretty quickly, and we're not quite sure how he does that, but there's some theories on that. Anyway, so they got a couple of Oompa Loompas, and they made a sled, and they tested out this sled dry weight, and they calculated its force normal to be at 52 newtons, and so they figured that they gave it a shove, and they found that it was moving just fine with 36 newtons. So they figured with two Oompa Loompas, they're able to actually get this thing moving without any weight on it. So they might have to, you know, get a couple more Oompa Loompas to pull this along. But anyways, they decided that probably the best thing for them to know is, as far as the surface of this sled on the concrete surface, what is the coefficient of kinetic friction on the concrete surface? Because once they know that coefficient, they can calculate how many Oompa Loompas they'll need to pull themselves around and their friends, and of course all their adoring fans, which are mostly girls. And so they decided to figure out, then they get their coefficient of friction on the TBS campus for this sled. And so their force of friction is going to be 36 newtons, because the idea of force of friction is it's always the opposing force equal to the force being pushed, right? So friction's always going to push back with an equal force, in one way or another on the force push. So the force of friction, we would say, is going to equal that 36 Newton push that they gave on it. And so that's going to equal their coefficient of kinetic friction times their force normal, which they calculated at 52 newtons for their sled. So it's pretty easy. They'll just divide this out. And so they find out that their kinetic coefficient of kinetic friction for the concrete on the metal sled is 0.69. All right, so now that they've got that, they can easily calculate how many Oompa Loompas they need. And they could make a sled that has a little bit less of a coefficient, because this is pretty high. But they figured, you know, instead of doing that, let's just buy more Oompa Loompas, because that would be cool. All right, and so then the next day they figure, well, you know, we need to make another sled so that the Oompa Loompas can pull our books around too. And so then they made another sled, and they stacked all their school books on it, right? And so this is what their school books look like. And they calculated that new sled with all of their school books on it to be 134 newtons. All right, so that was the force normal of the sled. So that's the mass times the force of gravity. And this sled they made a little bit better. They changed the runners from steel to kind of like a Teflon substance, and so they got a little bit different, a little bit of a better slide on this. And so the coefficient of static friction for this new sled design that they found was 0.55. So that's pretty good. So that's static friction. So that's the amount of that's the coefficient for static, so they have to break that in order to go. So they need to calculate how many Oompa Loompas it's going to take to pull that, right? So just to get it started, we're going to have to exceed this static friction. All right, so, so our static friction is going to be 134 newtons, and that, no, I'm sorry, our static friction we don't know. So our force of friction static is going to equal our coefficient, which is 0.55, times our force normal, which we know is 134. And this is going to tell them how many Oompa Loompas they need to pull their books around campus. So 0.55 times 134 equals 74 newtons, which is nice because that's exactly 3 Oompa Loompas, right? And these ones don't have arms. They're a little bit cheaper on eBay without arms. But they can tie the rope around their waist and stuff. So they've got this now, so they know how many Oompa Loompas they need to pull their books, and so they're working on the sled to pull themselves around, but at least they can get started by having these guys pull their books around campus, and that would be pretty cool.